Assalamualaikum warahmatullahi wabarakatuh and very good morning everyone. Welcome back to course SMBT 4663, the course of protein purification technique. So today I'm glad to say thank you very much to Dr. Nurhayati as the lecturer of this session. We're gonna assist the flow of group 10 presentation. Today we already have group 10 in front of us. I will introduce them based on their sequence order of presentation. The first one is introduction will be delivered by Nur Fuzla Aiman. And then the body part of presentation will be followed by Mardila, Sriana Sani, Jennifer, Zadia Jamaluddin, Nur Akmal, the Kartini Kabi, Aisha, and all of the conclusion will be summed up by the Wan Mulyati. Alright, so please give me the applause to group 10 to start their presentation. Please welcome.
Okay, Assalamualaikum and a very good morning to everyone. I am Nur Fuzla Aiman binti Muhammad Isri and I will be opening the introduction of our group. Today we will be presenting about continuous chromatography steps for purification of monoclonal antibodies, clinical use at large scale production. Okay, for the introduction, the SMCC, also called as Sequential Multicolumn Chromatography, is an open loop process for the separation of multi-component mixture using multiple buffers. The process combines two steps, SMCC, in this antibody procedure. The first one is protein A followed by anion exchange, and then the second one followed by polishing steps. The concept behind is to perform different steps in smaller columns connected in series and to maximize media utilization without any product loss. The difference of SMCC and batch is that a batch only use one column and everything is inserted in that column. But SMCC we divide it into 2 to 8 columns, so it will be different. It will be different step from the batch. Okay, next I pass to my friends.
Hello and very good morning everyone. My name is Marty LaCurahun. So for now, I would like to present how the SMCC build for monoclonal antibody was built. So the first thing that we need to do is to collect the relevant data during the batch chromatography optimization, and then that data will be incorporated into Bioscience Predict software, which is a software to enables the modeling or the simulations of the chromatographic system and the in silico optimization of the SMCC recipe. The parameter optimization was performed on a laboratory scale batch column, and the parameters that were optimized included the volume and monoclonal antibody concentration for the load, the flow rate of the loading step, buffer concentration along its volume and pH, and elution buffer conductivity for ion exchange. So this is the parameters that required to design the SMCC recipe using the software Bioscience Predict. The first parameter is the product or concentration, resin characteristic, column characteristic, the static and dynamic binding capacities, and lastly, the pressure at 3 different flow rates. The next part will be presented by fellow member Sriana. Thank you very much.
Assalamualaikum and a very good morning. My name is Sriana binti Sani and I'm going to explain about the cell culture. IgG1 subtype monoclonal antibody was chosen and produced in a batch culture using a stable CHO cell line in a 50-liter single-use bioreactor. CHO stands for Chinese hamster ovary, and the crude will be clarified using depth filtrations. After that, the purity of the IgG will be measured using the SDS page. If you can see from the screen, this is the characteristic of the clarified crude. Each of these characteristics will be measured using different method. For example, for the DNA, it measured using the Pickle Green method, and for the level of HCP, it was measured using commercial ELISA kit. For the next step, it will be explained by my friend. So that's all from me. Thank you.
Okay, hello, good morning. My name is Jennifer. Okay.
There's procedure called three-phase purification strategy that will apply in a large-scale production protein in industry. The first step is called capture and followed by intermediary and polishing. In the capture step, the objective is to isolate, concentrate, and stabilize the target protein, while the intermediary phase is to remove the bulk impurities, and the last step is polishing step to achieve the final impurities. Okay, let's take a look on the capture step. On the capturing step for the monoclonal antibodies, the first is to wash and dilution buffer was screened on the microplate and selected using an experimental design with two different protein media, A media which is A1 and A2. But we continue with A2 media because the A2 media produce high productivity compared with medium A1. And then after that, at the end of the first screening step, both the washing buffer and the dilution buffer was selected for media A2 choose based on the purity and the immunoglobulin recovery observed under static condition. For the washing buffer, the trace concentration we choose is 10 millimolar trace and on the pH of 8 because the recovery and the aggregate contents show high recovery and aggregate. And for the elution buffer, we use glycine buffer at the pH 3.7. Also because it shows the best immunoglobulin recovery and also lowest aggregations. Thank you.
Alright, so we will continue with the intermediary step. So basically, as explained by my friend earlier, it removes all the bulk impurities, and the focus is to separate the bulk from the target proteins such as other proteins, viruses, nucleic acids, and others. Alright, based on this topic that we're going to talk about, the separation conditions were screened for 11 different medias using microplate following the experimental design plan. And the medium IEX2 was identified as the most promising and loading elution conditions, and they were optimized. And the simulations by the BioSC Predict were used to determine the SMCC parameters, starting from the breakthrough analysis. And the computational optimization performed was driven by the optimization of media and also limit to resin-associated costs. And BioSC also runs were performed to verify the performance and to fine-tune the recipes.
Okay, hello. We move on to the final step for the protein purification is polishing step. This is very important step because we want to remove the other contaminant. In this journal, we want to remove the DNA and HCP. HCP stands for whole cell protein. And we use the gel filtration or membrane filtration chromatography. We separate based on their size. And this is to optimize the protein purification. They are used two type of media. First media is P1 and second is P2. The first media is used about 50 for sodium chloride and the second is 100. So you can see this HCP is 12 and 18 for DNA. And the last for the result, you can see the second media more purified for the monoclonal antibody recovery and their purity. And also they are remove more HCP and DNA. Okay, this is the final result. You can see the purity of protein recovery is higher, and also we have been removed HCP and DNA to the lowest number. Okay, thank you.
Okay, Assalamualaikum and good morning. My name is Kartini Bitikabi. So what is the advantages of SMCC? First and foremost, SMCC process requires only few additional data. This is because SMC design is not complex and its parameter already optimized in batch chromatography before implemented SMCC itself. Next, SMCC is systematic and adapted method for the production of monoclonal antibody prospect. And SMCC process also more flexible because limitations such as tank limitation and buffer storage capacity can be considered when design a process with existing facilities. And lastly, SMC also is cost effective because large production of protein within short time.
Hello, So my name is Aisha Hamina and I will explain on the disadvantages of SMCC. Since SMCC is the latest effective method to purify monoclonal antibody, we found only a few SMCC flaws. One of the example of the flaw is some validation method, for example, virus clearance and the resin lifetime need to be redefined. Besides that, SMCC is lack in technological solutions such as analytical tools that enable a real-time measure of a product-specific characteristic, for example, the aggregation rate and impurity level. Thank you.
Assalamualaikum. My name is Wan Mulyati. Okay, I just like to recap again what we are presenting today. Okay, the first one we talk about the optimization of the purification of monoclonal antibody by using two techniques. The first one we are using column chromatography, and the second one we are using SMCC, which is sequential multicolumn chromatography. Okay, then we also talk about the advantage and the disadvantage of using SMCC over the batch chromatography. However, we also have a challenge for the implementation of the SMCC at the industrial large-scale purification, and more generally when we are talking about the biopharmaceutical. Okay, so to conclude our presentation today, personally I think that we need a collaboration between the various parties such as the drug producer, the vendors, and also the authority, which will be critical to provide the right solution and the right answer for the production of the safer and more cost-effective biopharmaceutical. So, alright, we are done, and thank you for listening.
Alright, thank you very much for Group 10 for the very nice presentation today. So, today we open for Q&A session. Is there anyone have a question?
Assalamualaikum and good morning, Group 10. My name is Laila Dina Purba, and today I would like to ask a question about the monoclonal antibodies. In industrial application nowadays, what is the minimal requirement of the purity for monoclonal antibodies in order for it to be applied in the medical and also pharmaceutical industry? And also how the SMCC will help to achieve those purity requirements? Thank you.
My name is Jennifer. Okay, thank you for the question. The minimum purity for the antibodies is 90%. First, since we optimize this by the batch chromatography, we collect the data, and from the data from the batch chromatography, we can implement it in the SMCC. From the SMCC, it is an automated system. The purity percentage that can we get from the chromatography is higher. So, yeah. Alright, very imaginative answer from the Group 10. And we please, if there's another question, yeah, again from Wing A.
What are the methods for, the disruptor cell membrane? Method used to disrupt the cell membrane, so you want to purify the protein, the antibody. So that using it is sonicator or what, or something like that from the general.
Thank you for the questions. The answer for the questions is we use sonicator, and then we filter it. That's what's crude. Okay, thank you very much for your filter.
Players, put your pinky rings up to the moon. Girls, what y'all trying to do? 24 karat magic in the air. Head to toe so clear. Look out. Pop, pop, it's showtime. Showtime, showtime, showtime. Guess who's back again? Oh, they don't know. Oh, they don't know. I bet they know as soon as we walk in. Showed up, I'm wearing Cuban links, designer mix, Inglewood's finest shoes. Don't look too hard, might hurt yourself. Known to give the color red the blues. Woo, shit. I'm a dangerous man with some money in my pocket. Keep up. So many pretty girls around me and they're waking up the rocket. Keep up. Why you mad? Fix your face. Ain't my fault they all be jacking. Keep up. Players only. Come on, put your pinky rings up to the